Alright, hello everyone and welcome to the third POPX Introduction tutorial. If you haven't watched the other two, I highly recommend you to watch it before you continue with this video. The link is down below the description. So in the previous tutorial where we left off, we created this nice animation with the move along curve. And what I want now to show you is another kind of variation with the move along curve. I think it's personally my favorite operator in the POPX family. So let's start building this and see the effect. So I'm going to actually delete um, what we don't need here, and I'm going to instance a grid of boxes. So I'm going to reset all the settings to default. This will generate a grid, and I'm going to actually increase a bit its resolution, something like that. Now I want to create a shape falloff. I'm going to choose a spherical shape and going to reduce its radius, and let's preview the falloff. Let's make it a bit smoother with the transition range. Something like that I think will be great. I'm going to drop a move along curve and connect both the instances for the first input and the curve to the second one. Let's display this. Now in the move along curve, I'm going to reference my keyboard to the start pulse and set the mode to be solver. Currently, the instances are being attached by the closest point. So let's actually make this distribute. Now another thing I would like to do is to toggle on the snap centered to curve start. And if I reset, you can see that all the instances are snapped together into the curve at the same point. And I also um, can maintain their offset like that. So they basically move through the curve in one unit basically. I can also do a snap um, orient, but I think for this example, uh, we won't need this. Now a nice thing we can do is to go to the animate page and enable the fall off, and the fall off affects the speed. So now you can see that based on the fall off, our instances speed is being modulated. And in the attach mode, I can also play around with the offset ramp. So I want at the beginning the offset to be uh, a 1, and uh, as long as they move along the curve, they basically kind of like squeeze inside. And let's actually toggle off the warp wrap so we can see the effect better. Maybe increase the general speed. You can adjust your fall off over here if you want to uh, to make it more accurate. Let's also maybe scale them by the goal. Right, so let's also add some trails, because why not? So I'm going to connect a trail pop, and let's display the trails. So now you can see if I reset, I'm getting some kind of like weird artifacts. So maybe um, we can output the goal attribute over here, and we can, after the trail pop, insert a delete pop to split the line strip based on the goal attribute. I'm going to choose it, and let's see if it solves this. Yeah, I need to reference the keyboard in trail for the trail reset. Yes, so we can maybe make it lower. And a nice thing we can also apply is some twisting. So in the, we have two options actually. We can do it, whether we can do it in the animate, or we can do it in the attach on the curve itself. Let's choose to do it in the animate, increase it. Now we're not seeing any much of the effect. Maybe it's because we need to actually do the snap orient to um, snap them all together, and then we can see how they are rotating and twisting around the curve. Maybe lower the speed a bit. Okay, I think this is the system that I wanted to show you. You can obviously take it further and play around with it more, make it more complex. Next, what I want to show you is some utilities here on the tools. So let's start with the preview Falloff. So the preview Falloff simply previews any Falloff that you choose. So for example, um, if I have a Falloff, I can connect it over here and select the Falloff that I want to preview. Obviously, the Falloff is a float attribute, so any float attribute that you will choose here will be visualized by the preview Falloff. So, for example, you can visualize, let's think about the float attribute, um, maybe the index attribute, which won't be very useful, but it takes that, just that it will take any float attribute. So basically, the position in the y-axis, maybe on the x-axis, sorry, or the y-axis or the z-axis, but it's mainly there to basically visualize your Falloffs. Um, but also that, just that every Falloff operator has its own preview Falloff parameters. Next, I want to show you the Unpack. So the Unpack basically unpacks the um, POPX geometry. So let's actually just move these aside. So for example, if I created a POPX geometry here, and if I go look at the output, I can see it's like these packed points. But if I want to actually have the actual geometry itself and do other operations on the geometry itself and its primitives and everything, I can unpack it with the unpack. If I connect a null after the unpack, I can see that I have my actual geometry with all the primitives and everything. The unpack can also, you can disable the apply transform, so this won't apply the transformation. You can transform any attribute to the unpacked geometry, and you can also transfer groups. So for example, if I had a color, for example, I can randomize the color with the randomize. Let's go to the color and randomize the color. So I have randomized color for each instance. And in the unpack, I can just transfer this color. But if I don't see the color, it's because I need to basically force the uh, operator to cook. This is something that probably will happen a lot, because if it doesn't cook, it won't see the changes of the attributes. So now I can see the color and I can choose to transfer the color. And you can also do this for groups. So for example, I can just create a group with a group up based on, for example, the position in x-axis, and I can force them to cook again and transfer this group. So now you can see that I have the group on me on my actual geometry. So this is again useful if you want to further process your geometry, uh, but the actual geometry and not the packed points POPX geometry. So another useful POPX operators tools are the delete and the merge. So I won't get into them too much. I would just say that they basically apply the same kind of operation that the delete pop and the merge pop are doing, but it's just more compatible with the POPX geometry system. Another useful tool is the reorient. So let's actually clean a bit the network here. We can delete those. So the reorient basically creates a new attribute, which is the POPX orient. So when we generate a POPX geometry, we are generating also our orient attribute. And this is going to be our local frame of orientation for each instance. Now, for example, if I want to randomize my orientation of my boxes over here, I can use the randomize and randomize the orientation. So now I get random orientation and I can visualize it with the visualize frame. And you can see that the local orientation of each instance is being randomized. But now I want to uh, oops, sorry. I want to transform them. And when I do this, let me display this. They're going to be translated, rotated, scaled with their current orientation axis. But if I don't want to do this, if I want to apply random orientation or any other orientation changes, but then transform them in another local orientation frame. So this is where the orient operator is coming to help you. What I need is I just need to connect. Um, let's actually remove the visualize frame from here. I just need to connect my reorient, my instances to the reorient, and the reorient has two orientation sources. It can be from a point attribute on your actual instances or from a reference geometry. Let's start with the point attribute. So we can apply a new orientation based on a quaternion, two vectors, or a matrix. And each you can reference over here on the parameters. So for example, for an orient, we can just create a new orient attribute. We can call it like new orient. And if I initialize it, it needs to be a vector 4. And if I initialize it like this is going to be identical identity quaternion. So it's like kind of like an identity transform matrix. So I can plug it over here and choose it to be the quaternion attribute. And now if I connect the visualize frame and display it over here, you can see that my orientation is now different. And to see it better, if I bypass the reorient, I'm getting the original random orientation. And if I unbypass the reorient, my local orientation is the new orient attribute that I just defined. And now if I transform my instances, they are randomly oriented, but if I transfer them, oops, sorry, so they're going to be transformed based on the um, new orient attribute. So to visualize it better, maybe I will connect the visualize frame after the transform. And rotate them with the new orientation frame. Now another option is to use the reference geometry. So let's do that. I'm going to delete the randomize for now. Let's remove it. And let's instance actually a 3D grid. We can also increase a bit the size. And instead of creating a new orient, we don't need this anymore. We can create, for example, geometry, for example, a simple sphere. and I will connect it to the Orient mesh to create uh, an orientation for that sphere. And when I plug it in to the second input of the reorient and choose the reference geometry, I'm getting an error because the Orient mesh is actually creating an Orient attribute and not a new Orient attribute. So it's a different name. So I can just delete the new here. And let's see, it's connected to the visualize frame to see the effect. And now you can see that they're getting a different orientation frame. And you can increase the max neighbor distance because basically what it's doing is um, finding the closest point of the mesh and applying this orientation to that specific instance. So if I bypass this, you can see that the default orientation is the orientation that the instancer was generating. And if I unbypass the reorient, I'm getting kind of like a spherical orientation of on my instances. And if I transform them, for example, let's reset. If I transform them on the, let's translate them on the z-axis, and so you can see the effect. Oops, sorry. Or scale them or rotate them. So yeah, in general, this is a very useful um, tool to create new orientation frames for your instances. Um, so yeah, I think this is the end of this part of the tutorial. In the next part, we're going to look at more useful stuff, and also we will have a look on some simulations. So see you in the next tutorial. Thank you. Bye bye.